Hi there. So, in our last class, we had discussed about scalar and vector quantities, and we had also discussed about distance and displacement. Now, in this class, we're going to talk about speed and velocity. Now, why did we talk about scalar and vector quantities? So that we can understand how distance and displacement, though they look same, are vastly different things. Turns out, speed and velocity have a direct relationship with distance and displacement. How? Speed is mathematically defined as change in distance per unit, change in time. You want to make it simple? You can simply say distance upon time is speed. In the same way, we can define velocity as change in displacement over change in time. And again, want to make it simple, you can simply write displacement per unit time. Now remember, distance is a scalar quantity, and obviously time is also a scalar quantity because time has nothing to do with direction. Hence, speed is a scalar quantity. Displacement is a vector quantity. We have already talked about it. And time is a scalar quantity. Turns out velocity is a vector quantity. Now, what is the unit of speed? Now, if I talk about the unit of speed, turns out what is the unit of distance? The unit of distance is meters. Distance is nothing but the length of path covered, so it's meter. Fine. So, unit of speed is meter per unit second, or meter per second. You write it like this, or you write it like this. What is the unit of velocity? The unit of velocity is displacement upon time. And what is displacement? It is also a length, isn't it? A shortest length, but a length. Hence, the unit of displacement turns out to be meter per second. It's just the way the unit of distance and displacement, pardon me, it's not the unit of displacement, is the unit of velocity. My bad. So just the way the distance and displacement have the same unit, similarly, speed and velocity also have the same unit. Now, let us try to understand distance, displacement, speed, and velocity using a simple example. Okay, so I have a point A, I have a point B, and I have a point C. The distance between A and B is 100 meter. The distance between C and B is 20 meter. So person goes from A to B in 10 seconds. Then the person goes from B to C in another 5 seconds. The question is, what is distance, displacement, speed, and velocity for the entire journey? So let's start. Okay. Now, What is distance? The total length of path. So the person goes from A to B, which is 100 meters, and then the person goes from B to C, which is 20 meters. So the total length of path is 100 plus 20, 120 meters. Now, what is displacement? It is the shortest path. It is the shortest path. And what is the shortest path? It is the shortest part between the initial and the final points. So it is AC. Fine. So how do we write AC? AC is AB minus CB. So AB is 100 and CB is 20. So AC is 80 meters. You see, while the distance is 120 meter, the displacement turns out to be only 80 meters. Next, what is speed? Speed is distance upon time. What is the total distance here? 120 meters. What is the total time? The total time is 10 seconds plus 5 seconds is 15 seconds. So what is the speed? 8 meters per second. Now velocity. Velocity is displacement upon time. What is the displacement we found out? 80 meters. What is the time? 15 seconds. So that turns out to be 5.33 meters per second. This is the magnitude of the velocity. So you see, just by figuring out the distance and displacement, we can easily figure out speed and velocity. Okay, thanks for watching the video. In our next video, we are going to understand acceleration.